Good evening, everyone. Good evening, good evening, good evening. I welcome you all again to the JEE Enthuse. Hope all of you are doing great, having the good time at home. Well, people, if I'm audible and visible to everyone, hit the chat box with the thumbs up. Hit the chat box with the thumbs up if I'm audible and visible to everyone. Hi, Vaishnavi. Hi, Kushi. Hi, Abdul Hadi. Hi, Ashwarya. What's up? Good evening, everyone. Good evening. Good evening, Malik. Hi, Jasima. Hi, Rafia. Hi, Sahana. What's up? How are you guys doing? Good evening, guys. Good evening. Good evening. Welcome you all again to the JEE Enthuse. Well, people, let me know if you are super duper excited for the session. Let me know in the chat box with the thumbs up if you are super duper excited for the today's Mega Menti JEE 2021 session, in which I'll be conducting a quiz from the chapter Chemical Equilibrium. Let me know with the thumbs ups. Yes, Janan, Wassim Sir's army is back. That's wonderful. Yeah, that's great. That's great. Let me know fast if you guys are super duper excited for the session. Yes. Yes. Vaishnavi, the quiz will be for maximum of for an hour, yeah? Oh, Rafia is super duper excited. That's wonderful. Yes. Yes, Ankit, I'll be starting. Yes, Ankit looks super excited. Is that Ankit? Yes. Albert, I have no idea about it. Let me see if I get time. Definitely, I'll be helping you out in that batch as well. Yes. हाँ जी शाहिद फर्क हो गई मुझे. Yes. फर्क हो गई मुझे. All right, people. So let's get started with the today's session. Guys. Just give me a second. Yes. So people, if you want to participate in the today's Menti session, I want you all to go to the www.menti.com and log in there by using the code as 4627540. Okay. If you want to participate in the today's quiz session, what you guys are supposed to do, you guys are supposed to go to the www.menti.com and there you have to log in by using the code the 4627540. Yes. People, if you are super duper excited, if you actually want to participate in the quiz, you are supposed to go to the www.menti.com, log in there by using the code 4627540. Yes, do it fast. A lot of people are joining in because a lot of hearts I'm seeing over here. A lot of hearts are coming out. Yes, that means a lot of people are joining in. Albert, I'm doing wonderful. How are you doing? How are you doing? Janan has already joined. That's wonderful. Ankit has joined. Yes, that's wonderful. I want every one of you to join the session fast. People, go to the www.menti.com, log in by using the code 4627540. After logging in only, you can participate in the today's quiz session. Otherwise, you won't be able to participate, yeah? I want all of you to do it fast. I can see a lot of hearts are coming out. Yes, that means a lot of people are joining in. That's wonderful. Yes. Ankit, Canizaro reaction bhi padenge yaar. Tension na lo. Shahid has joined. That's wonderful. Khushi is saying green hearts are coming out. Yes, actually green hearts are coming out. Yes. People, I want you guys to join fast. Go to the www.menti.com, type the code 4627540 to log in. Yeah? Do it fast. Yes, Kirito, it's a quiz. It is a quiz. Yes, it is a quiz. Albert, I didn't see your doubt, bro. I'll check it out tonight. Okay, I'll let you know what it's all about. Yes, I'm doing wonderful, Basit. I'm doing wonderful. People, if you want to participate in the today's quiz session, I want all of you to go to the www.menti.com, type the code 4627540. Then only you can participate in the today's quiz session. Yeah. Janan, I did that last time. Okay, I'll do that tonight only. Okay, I'll do that tonight only. Ashwarya has joined in. That's wonderful. Vaishnavi has joined in. That's great. Yes, that's great, people. That's great. So do it fast. I want every one of you to go to the www.menti.com, type the code 4627540. Then only you can participate in the today's quiz session. Otherwise, you won't be able to do that. Okay? Yes. All right. Ankit, that's really important. You're supposed to make notes in chemistry. Absolutely, that's really important. Yes, Janan, I'll be posting in the Telegram group as well. Why not? All right, so let's get started. I hope all of you have joined in. All of you are ready to participate in the today's quiz session. And let me tell you guys, let me tell you, you guys are not supposed to answer the questions in the chat box. If any one of you will try to answer the questions in the chat box, you are going to get blocked at that time only. Okay, if you really want to participate in the quiz, you have to go to the www.menti.com. To log in, you have to use the code 4627540. Then only you can participate in the today's quiz session. All right. So let's get started. Let's get started with the today's quiz session. Okay. So before starting, let's see how many people have joined and what are the symbols which I'm getting right here. That's wonderful. It looks crazy. Yeah. All right, guys. Let's start the quiz. And the first question is on your screen. Just check your screens, guys. The first question is on your screen. The question was asked in JEE 2019, 12th April evening, yeah? In which of the following equilibria Kp is not equal to Kc? Very simple. Very simple question, guys. I want every one of you to give it a try. You have got exact 45 seconds to solve it and let me know the answer fast. Yes. Yes. That's wonderful, Shahid. That's great. Yes, Shahid, I'm absolutely fine. Yes. Rafia is saying it's done. Albert is saying it's an easy one. Yes. Prakash is done with the question. Kirito is done with the question. Yes. Wonderful. A lot of people are saying they're done with the question. People, you have got 15 more seconds to solve this question. It's a very simple question which was asked in JEE 2019 in 12th April evening session. Okay. Yes. Do it fast. The time is running out and the time is up. Let's see how many of people have marked it correctly. Majority of the people have given the correct answer. That's actually great. That's actually wonderful. Let's get to know the leaderboard also. Let's see the performance of yours. But before that, let me tell you how this question was to be solved. Okay, it was a very simple question. We have done these sort of simple questions in detail when I taught you the basics of the chemical equilibrium, if you remember. Yeah. People, if you remember, I gave you one relation between Kp and Kc. If you remember, Kp is equal to Kc RT to the power delta Ng. Yes, this was one relation which I gave you between Kp and Kc. Yes, and any reaction for which delta Ng will be 0, for that reaction I must say Kp is going to be equal to Kc. So for any reaction whose delta Ng will be 0, for that reaction Kp value is going to be equal to the Kc value. Right? And in this question, what was asked? In which of the following equilibria Kp is not equal to Kc? Okay, and you were given with the four options. Right? Okay, people, if you check the second option, if you check the third option, if you check the fourth option, in these three options, what you are getting delta Ng for the reaction as 0. Only in the first option, you are not seeing the delta Ng to be equal to 0. Yes, in this reaction, you are given with a reaction as the first option I'm considering, that is 2IC solid plus O2 gas. Yes, plus O2 gas in equilibrium with what? It's in equilibrium with 2 times carbon monoxide gas. This was the option number 1. Okay. Now people, if I want to calculate the delta Ng for the reaction, as you all must be knowing, in order to calculate delta Ng, we are supposed to look at the gaseous reactants and products only. Yes, and delta Ng, as you all must be knowing, is nothing. It is just number of moles of gaseous products minus number of moles of gaseous reactants, as you all must be knowing now. Yes, this is in gaseous form, this is in gaseous form, this is in solid form. I've got nothing to do with this. Yes, number of moles of gaseous products is simply 2 minus number of moles of gaseous reactants. Right here it is 1, so 2 minus 1 is 1. So for the first reaction, delta Ng is not equal to 0. If it is not equal to 0, that means for this reaction Kp value won't be equal to Kc. Yeah, it's a very simple question it was, right? Okay, let's move on and let's check the leaderboard, guys. Let's check the leaderboard. Let me see who is at the top. Wonderful, guys. Wonderful. Zlatan was the fastest to answer this question. Then we have got Bell, we have got Carl, we have got Casper, Tiger Baby, what a name it is, Clippy, then Dr. Evil, then DM Kids, then Puffy, then Room. Wonderful, guys. These are the people who have made it to the leaderboard. Wonderful, great job done. Let's move on to the next question, which is on your screen. In 3, 2, 1, and now, yes. The question is on your screen, guys. Have a look on the question. Yes, very simple question it is. At a certain temperature, only 50% of HI is dissociated into H2 and I2 at equilibrium. The equilibrium constant is. The question was asked in JEE April 9, 2014. Okay. Very, very simple question, guys. You have got exact 50 seconds to give it a try. I want every one of you to give it a try. Yes. Very, very simple. Very, very simple question it is. I want every one of you to give it a try. At a certain temperature, only 50% HI is dissociated into H2 and I2 at equilibrium. The equilibrium constant will be. Very simple question, guys. Yeah. Ankit, yes, I want you to make the notes as well. Yes, absolutely. A lot of people are saying it's done. Let's see who is going to kill the today's Menti session, guys. Let's see, let's check it out. Yes. Yes, very, very, very simple question it is, I must say. The time is up. The time is up. The time is up. And let me see. Okay, wonderful, guys. These many people are the ones who have made it, who have done the correct answers. Before showing you the leaderboard, let me show how this question was to be solved. Let me show you this. Let me show you this simple question, guys. This was asked in a JEE Mains 2014. Okay, people, first of all, as you all must be knowing, what is going to be the reaction right here? The reaction is going to be 2 times HI gas is in equilibrium with what? It's in equilibrium with H2 gas plus I2 gas. Yes, this is the reaction all about. This is the reaction right here. Okay. Now, people, what is the percentage dissociation of this HI right here? Percentage dissociation is 50, right? So can I say alpha value is going to be percentage dissociation divided by 100. I got the degree of dissociation, which is 0.5. Yes, I got the degree of dissociation. Yes. Now, people, at time t is equal to 0. At time t is equal to 0. Let's assume I've got A moles of this. This is going to be 0. This is going to be 0. Let's assume degree of dissociation is alpha. So at equilibrium, I must say I'll be left with A minus A alpha moles of this HI. Now, simple. 2 moles gives 1 mole. 1 mole gives 1 by 2 moles. A alpha moles are going to give A alpha divided by 2 moles of this H2 at equilibrium. Similarly, 2 moles gives 1 mole, 1 mole gives 1 by 2 moles. So A alpha moles are going to give A alpha divided by 2 moles of I2 at equilibrium. I got the moles of each reactant and product at equilibrium right here. I have the value of alpha as well. I have the value of alpha as well. Yes. So people, first of all, for this reaction, delta Ng is 0. For this reaction, delta Ng is 0. First thing, if I'll divide this by total volume of the container, if I'll divide this by total volume of the container, if I'll divide this by total volume of the container, can I get the concentration of each reactant and product right here at equilibrium? Absolutely. Now, people, I can simply write the Kc expression, equilibrium constant expression. Yes, I can do that. It's going to be concentration of H2, which is going to be A alpha divided by 2V multiplied by A alpha divided by 2V, right? Concentration of this divided by what? Divided by A minus A alpha divided by V raised power 2 over here. Yes. So what I'll be left with, I can say Kc value will be equal. Kc value will be equal. It's going to be A square alpha square. It's going to be A square alpha square divided by, isn't it going to be 4V square? Absolutely, it's going to be 4V square. And in the denominator, guys, in the denominator, we have got A minus A alpha square. Yes, we have got A minus A alpha square divided by what? Divided by what? Divided by V square. First of all, V square got cancelled. And if I take A square common right here, A square will get cancelled with this A square. So I'll be getting at the end, I'll be getting alpha square divided by 4 multiplied by 1 minus alpha square like this. Yes. And we have the value of alpha. We have the value of alpha. Alpha value is 0.5. Just put the value of alpha in this equation. You are going to get the value of Kc right here as 0.25, which we were supposed to calculate. And the Kc is going to be unitless right here because the delta Ng for this reaction right here is 0. Yes. Very, very, very simple question it was. Correct? Let's check the leaderboard now. Let's check the leaderboard now. Let me see who is going to be at the top now. Let's check it out. Let's check it out. Let's check it out. Let's check it out, guys. We have got Devil Ninja. Oh, Devil Ninja is at the top. Then we have got, oh, Devil Ninja Kiran Kumar 2. Then we have got Devil Ninja Kiran Kumar 1. Wonderful. Then we have got at the third place, we have got Janan Wassim Sir's fan. That's wonderful. Vote Goat is the fastest to answer this question. That's actually great. Then we have got Carl, we have got Clippy, we have got Rafia, we have got Hadi, we have got Musharrif, we have got Jasima. Wonderful, guys. Great job done. Let's move on. Let's move on to the next question. Let me see if you can solve that or not. Okay. Okay, this is the question number 3, guys. I'm starting the countdown in 3, 2, 1 now. The countdown has started. The countdown has started. I want every one of you to give it a try. Yes, the countdown has started, guys. For the reaction A plus B in equilibrium with C plus D, Kc value is given at 298 Kelvin. If the initial concentration of all the 4 species were 1 molar each, then equilibrium concentration of D is. You have got exactly 1 minute to solve this question. It's a very, very simple question. I've made you solve these sort of questions during the sessions itself, yeah? Very, very simple question it is, guys. I want every one of you to give it a try. Rafia is saying it's done. DM Kids is from Neat Elite. Wonderful. Srilata is saying it's done. Wonderful. Great. I want every one of you to give it a try. You have got exactly 33 seconds more to solve the question. Just do it properly. Ankit is saying it's done. Kiran Kumar is done already. Wonderful. Yes. Vignesh is saying it's done. That's actually great. You have got 15 more seconds, guys. 15 more seconds to solve this question. Vignesh is saying it's an easy question. Yeah, Vignesh, it's great if you find it easy. That's wonderful. And the time is up. Yes, the time is up. Yes, the time is up. Let's check, guys. Let's check. Okay, this much percentage of students have marked it correctly. That's wonderful. And before showing you the leaderboard, let me show you how this question was to be solved. Very simple question it was, guys. Very, very simple question. I was given you the reaction, and the reaction was something like this. A plus B in equilibrium with what? In equilibrium with C plus D. Yeah? And what is given in the equation? If the initial concentration of all the 4 species were 1 molar. Yes, at time t is equal to 0, the concentration of A is 1 molar, this is 1 molar, this is 1 molar, this is 1 molar. Yeah, it's given in the equation. Yeah. Now, people, at equilibrium, let's assume out of 1 mole of A, X moles have reacted. So how many I'll be left with? I'll be left with 1 minus X. This 1 minus X is the concentration of A right here at equilibrium. Similarly, this 1 minus X is going to be the concentration of this B at equilibrium. 1 mole gives 1 mole, so X moles are going to give X moles. Already you had 1 mole of C. Apart from that, X moles of X moles will be coming from this reaction, and similarly it's going to be 1 plus X, as you all must be knowing. We have discussed this in detail in the sessions. Yeah, I got the concentration of each reactant and product at equilibrium. I can simply write the equilibrium constant expression. Yes, I can write it. Kc is equal concentration of this multiplied by concentration of this divided by concentration of this into concentration of this. Can I say it's going to be 1 plus X multiplied by concentration of D? That's also 1 plus X divided by concentration of A, that is 1 minus X. Concentration of B, that's again 1 minus X. It's going to be 1 plus X square. It's going to be 1 minus X square. Can I simply say it's going to be 1 plus X divided by 1 minus X ka whole square? Yes, I can say that. And people, are we given with the Kc value? Absolutely, Kc value is given as 100. Kc value is given as 100. Okay, just take root on both the sides. Can I say 10 is equal 1 plus X divided by 1 minus X? So what is the value of X which we'll be getting from here? It's going to be simply 10 minus 10X is equal to 1 plus X. Yes, absolutely, right? So people, it's going to be simply, this is 10. Take this one here, 10 minus 1 is 9, and take this 10 on this side, it's going to be X plus 10X, which is going to be 11X. So from here, you'll get the value of X right here. X value you're getting as 9 by 11, right? You got the value of X as 9 by 11. What was I supposed to calculate? I was supposed to calculate the equilibrium concentration of D. Equilibrium concentration of D is 1 plus X. This is the concentration of D at equilibrium, right? This is what I was supposed to calculate. I'm simply writing concentration of D at equilibrium is equal to 1 plus X, and already we got to know the value of X. Yes, so it's going to be 1 plus X value. How much we got? We got it as 9 divided by 11. If you solve this value, you are going to get it exactly as 1.818, right? And if I'll ask you, what are going to be its units? Leave the units aside, your answer will be 1.818. Yeah. So let's check the leaderboard, guys. Let's check the leaderboard right here. Let's check the leaderboard right here. Let me see who is at the top now. Let's see who is at the top now. Let's see who is at the top now. Kiran Kumar is still at the top. Kiran Kumar 2 as the top. Kiran Kumar 1 is at the second place. Then we have got Hadi at the third place. Hadi has come up. Wonderful, Hadi. Then we have got Jagdish. Wonderful. Great, Jagdish. We have got Janan, Wassim Sir's fan. Right. We have got Farkanda, who was fastest to answer this question. That's great. We have got Neha on the leaderboard for the first time. Wonderful, Neha. Then we have got Carl. We have got Albert for the first time. Wonderful, Albert. We have got Rafia again on the leaderboard. Wonderful, guys. Great job done. Okay. I'm moving on to the next question. Let's see if we can solve that or not. This is the fourth question. I'm starting the countdown in 3, 2, 1, and now. I have started the countdown. Yes. A solid XY undergoes decomposition to form a mixture of gases X and Y at temperature T. The equilibrium pressure is 10 bar Kp for the reaction. Very, very, very simple question it is. Yes. Very, very, very simple question it is. Let me see who is going to kill this question now. You have got exactly, guys, 50 seconds to solve it. Yes, you have got exactly 50 seconds to solve it. I want every one of you to give it a try properly. Okay. I want every one of you to give it a try. Yes, Ankit, you can do that. Yes, Ankit, you can do that. That will be perfect for you. That's great, Ninja, if you did this question already. Yeah. That's wonderful. You have got 25 seconds, guys. 25 seconds to give it a try. Yes. "15 seconds. 15 more seconds. Yes. 10 more seconds. Okay. Let's see who is going to be at the top now. The time is up. The time is up. The time is up. Okay, majority of the students have done it properly. Very simple question it was, guys. Very, very simple question. Let me let me give you the hint of how this question was to be solved. We have got a solid XY. Yes, we have got a solid XY. We have got a solid XY, right? It was undergoing decomposition, right, to form a mixture of gases X and Y. We have got X right here as the gas and Y right here as the gas. Yes. This solid XY, what happened to this solid? Decomposition happened and this solid XY got converted into X gas plus Y gas. Okay. So what are we supposed to calculate? The equilibrium pressure is 10 bar. The total pressure of the container in which this reaction was taking place is 10 bar at equilibrium. So I'm writing the total pressure at equilibrium is equal to 10 bar. What are we supposed to calculate? What are we supposed to calculate? Just look at it. The equilibrium pressure is this. Calculate the Kp for the reaction. Okay. See, guys, let's assume at equilibrium pressure due to X is P. So pressure due to Y is going to be P as well, because the stoichiometry right here is 1:1:1. Okay. So I have the partial pressures of X and Y at equilibrium, which are P and P respectively. Okay. People, if I want you to calculate the total pressure at equilibrium, total pressure at equilibrium is simply going to be the sum of these two pressures, which is going to be 2P. Yes, because this in gaseous form, this in gaseous form, this in solid form. It is not going to contribute to any of the pressure of the container at equilibrium. Yes, very simple. So people, total pressure at equilibrium is given to me as 10 bar. All right, it's given to me as 10 bar. So P value I got as 5. P value I got as 5. People, if I got the P value, can I simply write the Kp expression? Kp expression is going to be partial pressure of this raised power stoichiometric coefficient 1 multiplied by partial pressure of this at equilibrium raised power stoichiometric coefficient and divided by partial pressure of this. Since it is in solid state, its active mass is taken as 1. So Kp expression is simply going to be P square. P value we got, it's going to be 5 square. That means 25 right here. Okay, this 25 right here is the value of your Kp, which was the correct one. Okay, let me see the leaderboard. Let's see who is at the top now. Let's see who is at the top now. Let's see who is at the top now. Again the Kiran Kumar is at the top. Kiran Kumar 2 at the top. Then we have got Kiran Kumar 1 at the second place. We have got still Adi at the third place. Jagdish at the fourth place. Janan, Wassim Sir's fan at the fifth place. Then we have got Albert, chemistry virgin, wonderful. Then we have got Dev Khatri. Wassim Sir is the best. Wonderful, Dev Khatri. Welcome to the leaderboard. We have got Aditya Ray. Aditya, welcome to the leaderboard. Shana was the fastest to answer this. Wonderful, Shana. We have got Musharrif, who is at the leaderboard right now. These are the people who have made it to the leaderboard, guys. I'm moving on to the next question. I'm starting the countdown in 3, 2, 1, and now the countdown has started. The countdown has started. Yes. The countdown has started. When two reactants A and B are mixed to give products C and D, the reaction quotient Q at the initial stage of the reaction. AIEEE 2000 question. Okay, very simple it is, guys. Very simple. Yeah. Reaction quotient. Whenever we write the expression for equilibrium constant at any time apart from equilibrium, we call that expression as the reaction quotient. Yes, I think you should kill this question, guys. It's a very simple question, and this was asked in your AIEEE 2000 when I was 5 years old. Yeah. That's great, Kiran. If you're done with this, Srilata is also done. You have got 10 more seconds to solve this. Yes. Yes. The time is up. The time is up. We have got majority of the students who have marked it correctly. Wonderful, guys. It was a very simple question. At time t is equal to 0, at initial conditions, Q value starts to increase. Because when at time t is equal to 0, what happens? The reaction will be about to start, and when the reaction starts, concentration of products will start to increase, concentration of reactants will start to decrease. So the value of Q, reaction quotient, increases with time, right? Very simple. So what was the answer of this question? The value of reaction quotient increases with time. Yes, very simple question it was. Let's check the leaderboard. Let's see who is going to be at the top. Kiran Kumar is killing it. Yes. Okay, we have got Kiran Kumar at the first position, then we have got Kiran Kumar at the second, we have got Hadi still at the third one, Jagdish at the fourth one, Albert is there. Okay, then we have got Dev Khatri, Wassim Sir is the best, then we have got Aditya Ray is the fastest to answer this question, then we have got Janan Wassim Sir fan, wonderful, then we have got Amir, we have got Carl over here on the leaderboard. Wonderful, guys, great job done. I'm moving on to the next question. Let me see if you can kill that as well or not. Okay. I'm starting the countdown in 3, 2, 1, and now the countdown has started. Yes, look at your phones, guys. Look at your phones. Look at your screens. Very simple it is. Very simple it is. Select the correct option. Select the correct option. You are supposed to select the correct. For the reaction, SO2 gas plus half of O2 gas gives twice SO3. If Kp is equal to KcRT to the power x, where the symbols have the usual meaning, the value of x is. Assume ideally. The question was asked in JEE 2014. Very simple question it is. Okay. Very simple question it is. Yeah. You have got 35 seconds to give it a try. Srilata is saying the question is done. That's wonderful. Yes. Yes, that's great. That's great. If you guys are liking it, that's wonderful. That's actually wonderful. You have got 15 more seconds to give it a try. Yes. Oh, what happened? Oh, the time is up. How come? I have no idea. Okay. So people, majority of the kids have marked it correctly. Let's check the leaderboard. Then I'll show you how this question was to be solved. Okay. Let's check the leaderboard now. Wonderful. We have got Kiran Kumar 1 at the first position. Then we have got Kiran Kumar 2 at the second one. We have got Hadi still at the third one. Hadi is very struggling to go up. Yes, Hadi. Okay, we have got Jagdish at the fourth position. Dev Khatri is the fastest to answer this question. Wonderful, Dev Khatri. We have got Aditya Ray. We have got Janan. We have got Albert. We have got Amir. We have got Uncharted as welcome, Uncharted. Welcome to the leaderboard. Okay, welcome. So let me show you first of all how this question was to be solved. Yeah, this was the question, okay, and its correct answer was -1/2, right? Let me show you how this question was to be solved. Very simple question, guys. See, I told you Kp is equal to KcRT to the power delta Ng. Yes, and over here, the relation which is given to me as Kp is equal to KcRT to the power x. Just compare these two relations. Can I say your delta Ng is actually the value of x? Yes. So the value of x right here is actually the value of delta Ng. And delta Ng, as you all must be knowing, number of moles of gaseous products minus number of moles of gaseous reactants. Now we will check the number of moles of gaseous products. See, the reaction is already balanced. The number of moles of gaseous products are 1. And how many moles of gaseous reactants do we have? This is gas. So 1 plus 1/2. That means 3/2. You are getting the value as -1/2. So the value of x right here is going to be -1/2, which was my correct answer. Yes. So option B was the correct one among all. Correct. Now people, I'm moving on to the Next question, I'm moving on to the next question. I'm going to start the countdown in 3, 2, 1, and now. The countdown has started. The countdown has started. Look at your phones, guys. It's a very, very simple question. The question was asked in JEE 2003. For the reaction equilibrium, N2O4 gas gives twice NO2 gas. The concentration of N2O4 and NO2 at equilibrium are this much and this much. The value of Kc for the reaction will be. Very, very, guys, is it actually a question? I don't think so, yeah? And this question was asked in your JEE 2003. You can look at the question, yeah? Yes? Yes? Srilata is done with the question. That's wonderful. I want every one of you to give it a try properly. You've got 20 more seconds to give it a try. Yes. 20 more seconds, 17 more seconds. Very, very, very simple question, guys. Very simple question, yeah? Yes. 3, 2, 1, the time is up. The time is up. The time is up. Let's see how many people, or majority of the people, have given the correct answer. That's actually wonderful. That's actually wonderful. Let me see the leaderboard first, then I'll show you how this question was to be solved, okay? Let's check the leaderboard. Let's check the leaderboard. Let's check the leaderboard. Oh my goodness. Oh my goodness. First 3 positions are still going to be the same, yeah? Yes, we have got Kiran Kumar 1 at the first position, then we have got Kiran Kumar 2 at the second one, we have got Hadi still at the third one. Hadi is very struggling to go to the second or the first one. We have got Dev Khatri, wonderful. We have got Jagdish, we have got Janan, we have got Aditya, we have got Uncharted. Farkhanda was the fastest to answer this question, and we have got Albert. Wonderful, guys, great job done. Okay. So let me show you how this question was to be solved. The correct option is going to be 3 into 10 to the power minus 3 moles per liter, right? Very, very simple question it was, correct? I was given the reaction N2O4 gas in equilibrium with twice NO2 gas, right? The concentration of N2O4 and NO2 at equilibrium are this much and this much respectively, the value of Kc. I'm given with everything, right? Yes, I'm given with everything. Kc value, Kc expression is going to be concentration of NO2 at equilibrium raised power stoichiometric coefficient divided by concentration of N2O4 raised power its stoichiometric coefficient. Isn't it going to be concentration of NO2 at equilibrium? How much that is? Concentration of NO2 at equilibrium, that is 1.2 into 10 power minus 2. That is 1.2 into 10 to the power minus 2. I'll take the square of it. Yes, divided by concentration of N2O4. It's given as 4.8 into 10 to the power. How much it is? It is 10 to the power minus 2. People, when you'll solve this, you'll get the exact value as 3 into 10 to the power minus 3 moles per liter right here. Yes, so the option number B was my correct one. Wonderful, guys, who have made it correctly. It was a very, very simple question, and see what kind of question was asked in your JEE 2003, okay? I'm moving on to the next question. Let me see if you can solve that or not, okay? Let me start the countdown. Let me start the countdown in 3, 2, 1, and now. The countdown has started. The countdown has started, okay? Again, JEE 2012 question, guys. 8 moles of AB3 are introduced into a 1 decimeter cube vessel. If it dissociates as this, at equilibrium 2 moles of A2 are found to be present, okay? The equilibrium constant for the reaction is very simple question it is, guys, yeah? Actually, it's a very simple question. You've got exactly 1 minute to solve this question, guys. I want every one of you to give it a try properly, okay? Janan is saying the question is done. That's wonderful, Janan. Soumya, you're not supposed to write the answer in the chat box. You'll get blocked, okay? Go to the menti.com, use the code, then only you can participate in the quiz, okay? Srilata is done with the question. That's great. Manisha is done. Jagdish is done. Yes, Hadi, exactly. Lot of your previous year JEE questions have been repeatedly asked in your NEET examination these years, okay? I know, Jagdish, I know you're a NEET student, I know. It's actually great if you are looking at these questions, if you are giving the questions properly, correctly, and you're coming the leaderboard, that's wonderful, yeah? Yes, the DM kids, I know you're the NEET student as well. I know Hadi is the NEET student as well. Yes, I know. You've got 5 seconds. The time is up. Let's check Okay, majority of the kids have given the correct answer. That's actually great. That's actually great. Okay, let's check the leaderboard first, then I'll show you how this question was to be solved. Okay. Yes, something is going to change right now. No. It's still the same. It's still the same. We have got Kiran Kumar at the first position. We have got Kiran Kumar at the second position. We have got the Hadi is at the third. Then we have got Dev Khatri at the fourth one. Jagdish fifth one. Janan at the sixth one. Then we have got Aditya. We have got Amir. We have got Ruchir. Welcome Ruchir to the leaderboard. Then we have got Jasima, the fastest one to answer this question. Wonderful, guys. Wonderful. Great job done. Let me show you how this question was to be solved. See, guys, the correct option was 27, option number C, correct? Now, let me show you how this question was to be solved. We have solved these sort of questions in detail, right? We have solved these sort of questions in detail. I was given the reaction. See, first of all, 8 moles of AB3 are introduced in a 1 decimeter cube vessel. If it dissociated like this, we have got the reaction like this, twice AB3 gas. It's an equilibrium with what? It's an equilibrium with A2 gas plus 3 times B2 gas, right? So your AB3 is dissociating something like this. At equilibrium, 2 moles of A2 are found to be present, okay? I'm given with the moles of A2 at equilibrium as well. The equilibrium constant for this reaction will be. Very simple question it is. See, guys. So initially at time t is equal to 0, I have got 8 moles of this AB3. So this is going to be 0. This is going to be 0. Yes. Let's assume at equilibrium, out of 8 moles of AB3, let's assume X moles have dissociated. So I'll be left with 8 minus X moles of AB3 at equilibrium. Since 2 moles gives 1 mole, 1 mole will give 1 by 2 moles. So X moles are going to give X by 2 moles. Yeah. Now, 2 moles are going to give 3 moles. 1 mole gives 3 by 2 moles. X moles are going to give 3 by 2 multiplied by X moles. Yes. So I got the moles of each reactant and product right here at equilibrium. Okay. At the same time, I'm given with the volume of the container as well, which is 1 decimeter cube. 1 decimeter cube is 1 liter. So divide by 1, divide by 1, divide by 1. So these are the concentrations of each. See, first of all, these are the moles as well as concentrations of each reactants and products at equilibrium. Yes. Now, what is given to me? At equilibrium, 2 moles of A2 were found. The moles of A2 at equilibrium is X by 2. Yes. Moles of A2 at equilibrium as per the equation, it is equal to how much? It's equal to 2, and we know number of moles at equilibrium for A2 is X divided by 2. So X divided by 2 is 2. So X value you are getting as 4. People, if you are getting X value as 4, so 8 minus X, 8 minus 4 is 4. This is going to be 4 by 2, that means 2. This is going to be 3 multiplied by 4, 12. 12 divided by 2 is 6. So these are your moles as well as concentrations of reactants and products at equilibrium. If you got the concentrations of each reactants and products at equilibrium, you can simply calculate the value of Kc. Yes, Kc value is going to be concentration of A2 at equilibrium, which is 2 molar. Yes, raised per stoichiometric coefficient 1 multiplied by concentration of B2 at equilibrium, which is 6 raised per 3 divided by, what is this 3? 3 is the stoichiometric coefficient, divided by concentration of AB3 at equilibrium, which is 4 to the power 2. You are going to get the value right here exactly as 27. Yes, so 27 is the value of Kc right here. And if I'll ask you what are going to be the units of this Kc right here, it is simply moles per liter to the power delta Ng. Delta Ng is 3 plus 1, 4, 4 minus 2, 2. So it's going to be moles per liter raised power 2. So 27 moles per liter raised power 2 is going to be the exact value of the equilibrium constant Kc right here for this question. Okay, wonderful. Let's move on and let's try to go to the next question. Okay, the next question, guys, I'm starting the countdown in 3, 2, 1, and now the countdown has started. Okay, the countdown has started. What is the equilibrium expression for the following reaction? AIEEE 2004. See this, which kind of question was asked, guys? Yes, you should kill this question. You should actually kill this question. You should actually kill this question. You have got 44 seconds. Sorry, 39 seconds you have. 39 seconds. You have got 36 seconds now to answer this question. I want every one of you to give it a try properly, okay? I want every one of you to give it a try properly. It's a very simple question. Yes, Jagdish, it's an easy peasy question. Janan is done, Ashwarya is done, DM Kids is done, Srilata is done, Jagdish is done. That's wonderful. Yes. Still you have got 10 more seconds to solve this one. Three, two, one. The time is up. Yes, the time is up. Yes, the time is up. Majority of the kids have marked it correctly. Wonderful, guys. Wonderful. Let's check the leaderboard first. Okay, let's see the leaderboard. Let's see the leaderboard. Let's see the leaderboard. Let's see the leaderboard. Okay, wonderful, guys. Again, we have got Kiran Kumar 1 at the first position. We have got Kiran Kumar 2 at the second position. Then we have got Adi at the third position. We have got Jagdish. We have got Devkatri. We have got Janan. We have got Amir. Uncharted is there. Uncharted is the fastest one to answer this question. We have got Aditya. We have got Ruchir. Welcome, Ruchir. Welcome, Uncharted. Welcome, Amir, to the leaderboard. Welcome, welcome, welcome. Yes. Yes. Let's see how this question was to be solved. People, very, very simple question it is. What is the value of equilibrium constant for the following reaction? Yes, this is in solid form. Its active mass is unity. It's in gaseous form. This is in solid form. Its active mass is unity, right? So can I simply say the equilibrium constant expression is going to be concentration of product, which is in solid form. Its active mass is 1 divided by this in solid form, active mass 1. This is in gaseous form, so concentration of O2 to the power stoichiometric coefficient, that is 5. Okay, is there any option which resembles with us? Yes, option number D, guys. Option number D is the one which resembles to this. So option D was the correct one. Wonderful. People, if you're actually liking this session, do like the video, share and subscribe to this channel, subscribe to the channel at the same time so that everyone will get benefited out of these sessions. Okay, I'm moving on to the next question. I'm going to start the countdown in 3, 2, 1. Now, the countdown has started. The countdown has started. Look at your phone, guys. Consider the following reversible reaction. Okay, we are given with 2 reactions. We have to check the relation between K1 and K2. JEE 2019, 9th January evening question. Very simple, very, very simple question. Yeah? You have got exactly 1 minute to give it a try. Okay? Exactly, I'm giving you 1 minute to solve this one. Yes. Yes. I want every one of you to kill this one as well. Yeah. And you can do that. Trust me. It's a very simpler one. Yeah. It's a very, 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 very simpler one. Okay. Okay. 30 more seconds. 30 more seconds you have. Give it a try properly. Give it a try properly. Yes. Give it a try properly, guys. It's a very, very simpler one. It is a very, very simpler one. Yeah. 15 more seconds. Yes. Yes, Kirito. Previous year JEE was epic. Yes. The time is up. The time is up. Majority of the students have given the correct answer. That's actually great. Now, people, let's check the leaderboard first. Then I'll show you how this question was to be solved. Yeah. Yes. Let's see how the positions getting interchanged or not. Okay, okay, okay. First 3 positions are still the same. Wonderful. Okay, first 4 positions are still, no, first 5 positions are still the same. Then we have got Janan, we have got Uncharted, we have got Aditya, we have got Amir, and some other guy, namely as I. Welcome I to the leaderboard. Welcome I to the leaderboard. Okay, let me show you guys how this question was to be solved. It's a very, very simple question. First of all, I was given with 2 reactions. Yes, I was supposed to check what is the relation between K1 and K2. What is the relation between these equilibrium constants K1 and K2? Okay. See, guys, understand. First of all, if I'll try to reverse the first reaction, my first reaction becomes like this. If I reverse the first reaction, it becomes like this. 2 times AB gas is in equilibrium with A2 gas plus what? Plus B2 gas. Yes. What is going to be its equilibrium constant now? Is it going to be K1 or 1 by K1? I reverse the reaction, so its equilibrium constant is going to be 1 by K1. Yes. Now, people, if I'll multiply this reaction by 3, it's going to be 6 times AB. 6 times AB gas in equilibrium with 3 times A2 gas. Yes. Plus 3 times B2 gas. Yes, since I multiplied this reaction by 3, so that 3 goes to the power of the equilibrium constant. Yes, it's going to be something like this. Now, people, can I say this equation right here and this equation right here, they are the same? Yeah. So should I be saying equilibrium constant for this and equilibrium constant for this are going to be same? Yes. So can I say K2? Can I say K2? Let me erase it first. Can I say simply K2 will be equal to 1 divided by K1 to the power what? To the power 3. Yes. So people, very simple. I can simply write K2 is equal to, I'll take inverse of it. It's going to be K1 to the power what? To the power minus 3. Yeah. So correct option is option C right here for this question. Okay. Yes. Saurabh, every day I'm taking chemistry sessions, bro. Yeah. Yes. Okay. Let's move on. Let's move on to the next question. Let's move on to the next question, guys. Let me start the countdown in 3, 2, 1, and now the countdown has started. Yes. Yes. You have got 1 minute 15 seconds to solve this one as well. It's again a very simple question, yeah? Yes. Very simple question it is, guys. You have got 55 seconds. You have got 55 seconds. Prince, if you want to answer the question, you can go to the menti.com, you can use the code, you can then participate in the quiz, right? Srilata is saying it's done. Yes. Jay Ajanke, you can go for the N. Awasthi. Yeah, that's a wonderful book for physical chemistry. You have got 27 seconds, guys. 27 seconds. Yes. Yes. Parvesh Kumari, can you see my comment? Which comment are you talking about, Parvesh? You have got still 5 seconds, guys. 5 seconds. Akram, if you want to participate in the quiz, you have to go to the menti.com. You have to use the code. Then only you can participate in the quiz. Yeah. Okay. Let's see. Okay. Wonderful, guys. It was a very simple question. Before solving this question, let me show you the leaderboard first. Let's see who is going to be at the top. I think Hadi is going to overtake. Is that? Hadi is at the first position now. It's actually wonderful. It's great, okay? After struggling for a lot of time, Hadi has come up at the first position. That's wonderful. Great job. Yes. Okay. Hadi is at the top. Then we have got Kiran Kumar, the second one. Kiran Kumar 2 at the third one. We have got Dev Khatri, the fastest to answer this question. We have got Jagdish. We have got Janan. We have got Aditya. We have got Uncharted, Amir, and I. Wonderful, guys. Great job done. Great job done. Okay, let me show you how this question was to be solved. The question was asked in JEE 2019, 8th April evening. Very simple question, guys. You can kill this one, I'm telling you, right? See, first of all, we are going to calculate the equilibrium constant for this reaction, okay? And I'm given with two reactions, 1 and 2. This is the reaction number 1, this is the reaction number 2. So first of all, for this reaction, I'm supposed to calculate the equilibrium constant. So I'm going to make this reaction from the given reactions. I'm going to make this reaction from the given reactions. Yes. And the reaction which I need to make in this reaction, SO2 must be on the left side. Okay. So what I'll be doing, first of all, I'll be reversing the first reaction. If I'll reverse the first reaction, it's going to be SO2 in equilibrium with sulfur solid plus O2 gas. I reverse the first reaction. So it's equilibrium constant, which was 10 power 52. Now it's going to be 1 divided by 10 power 52. Yes. Now people just think over it. I should have twice SO2 right here. Okay, but I got SO2. So I'm going to multiply this reaction by 2. Let's multiply this reaction by 2. So if I'm multiplying this reaction by 2, it becomes 1 divided by 10 power 52 square. Yes. And people, this second reaction I'm writing as such. Isn't it going to be twice sulfur solid plus 3 times O2 gas in equilibrium with 2 times SO3 gas? And right, its equilibrium constant is 10 to the power 129. Correct? Very simple. Now people, if I'll simply add these two reactions, on adding these two reactions, can I say this twice solid, this twice solid got cancelled? Yes. This is 3 times O2, this is 2 times O2. Yes. So I'll say there'll be 1 O2 present on the left hand side still. So isn't it going to be 2 times SO2 plus O2 in equilibrium with what? In equilibrium with 2 times SO3 gas. Yes. People, can I say I made this reaction for which I was supposed to calculate the equilibrium constant? Yes. And how I made this reaction is when I added these two. Yes. And we know, we have discussed in detail, when we add two reactions, their equilibrium constants are multiplied. Yes. This was the equilibrium constant of the first one. This was the equilibrium constant for the second one. I have added the two reactions. So I have to multiply their equilibrium constants. It's going to be 10 to the power 129 multiplied by 1 divided by 10 to the power what? 52 ka square, which is going to be 10 to the power 104. Yes. So people, what do you think will be the value? The value is going to be 10 to the power 25. 10 to the power 25 is going to be the correct answer for this question. So wonderful guys who have made it correctly. That's actually great. Okay. I'm moving on to the next question. Now be careful and do the questions properly. Be careful guys. Okay. Be careful. Hadi is at the first position. Hadi, you have to be careful, okay? Otherwise, Kiran is going to kill it. I'm telling you, okay? You have to be careful with the questions, right? Okay, I am moving on to the next question. I'm starting the countdown in 3, 2, 1, and now the countdown has started. Look at your phone, guys. This is the question. The value of Kc is 64 at 800 Kelvin for the reaction. The reaction is given to us. The value of Kc for the following reaction is. The question was asked in JEE 2020, 6 September evening. Okay, very simple question. I'm giving you exactly 1 minute to solve this question. Let me know the answer fast. Yeah, you have to let me know the answer fast. Janan is saying it's done. DM Kids is saying it's done. Srilata is saying it's done. That's wonderful. Jagdish is also done with the question. Okay, wonderful Jagdish. It's a very simple question, guys. You have got 30 more seconds to solve it. Let me know the answer fast. Yeah. Let me know the answer fast. Yes. Everyone is saying it's done. Yes. Yes. Still 19 seconds. People, give it a try. Give it a try fast. Yeah. Exactly, Dev. Exactly. It's an easy peasy question which was asked in this year JEE in the September 6th April session. Yeah. 3, 2, 1. The time is up. Yes, the time is up. Before showing the solution of this question, we are going to see the leaderboard. As you can see, majority of the kids have marked it properly. That's actually great. Let's check the leaderboard first. Let's see the leaderboard. Yes. All right. Hadi is still at the first position. Then we have got Devil Ninja Kiran Kumar 1 at the second position. Oh, Dev Khatri has moved the third one. That's wonderful. Then we have got Kiran Kumar second at the fourth position. Then we have got Jagdish, we have got Janan, we have got Aditya, we have got Uncharted. DM Kids was the fastest to answer this question, and welcome DM Kids to the leaderboard. And we have got Amir at the leaderboard as well. Yes, Dev, you are killing it. Okay, I don't know what is happening to Kiran Kumar. Kiran Kumar, you have to look at the phone correctly, bro. Okay, I'm moving on, and let me show you how this question was to be solved. Then I'll move on to the next question. Yeah. See guys, it's a very simple question. First thing, the value of Kc is 64 at 800 Kelvin for this reaction, right? This is the reaction for which Kc value is 64, correct? The value of Kc for the following reaction is, okay, fine. I'm supposed to calculate the Kc for this reaction, okay? The reaction for which we are supposed to calculate Kc, we are going to make this reaction from the given reaction, okay? So what do I need to do? I'm going to reverse the first reaction. If I'll reverse the first reaction, it becomes like this: NH3 gas in equilibrium with N2 gas plus what? Plus 3 times H2 gas. Yes. And on reversing the reaction, what happens to the equilibrium constant? Equilibrium constant is inversed, as you all must be knowing. Now the equilibrium constant for this reaction is going to be 1 by 64. But still guys, this reaction and this reaction are not matching. So what am I supposed to do? I'm supposed to multiply this reaction by 1 by 2. Yes. If I'll multiply this reaction by 1 by 2, it becomes NH3 gas in equilibrium with half of N2 gas plus what? Plus 3 divided by 2 times H2 gas, right? And if I'm multiplying this reaction by 1 by 2, that 1 by 2 goes to the power of the equilibrium constant. So it's going to be 1 by 64 raised power 1 by 2. That means 1 by 8 is going to be the correct one. Yes. So option D was the correct one. Wonderful guys. Great job done. Yes. Okay. All right. I'm moving on to the next question, guys. Yeah. This is the question number 13. The second last question, guys. So do it properly. Okay. Make sure you do it correctly. Okay. I'm starting the countdown in 3, 2, 1. And now the countdown has started. The countdown has started. Look at your phone, guys. Select the correct option. The question was asked in JEE May 26, 2012. 1 mole of O2 and 2 moles of SO2 were heated in a closed container vessel of 1 liter capacity at 1098 Kelvin. At equilibrium, 1.6 moles of SO3 were found. The equilibrium constant Kc for the reaction would be, right? This question was asked in JEE May 26, 2012, right? I want all of you to give it a try. You have got exactly 1 minute to solve this question. Yes. Hi, Anamika. How are you doing? Hello, Umar. Welcome. Welcome, guys. Yes. Yes. Surjit, Arpan. Guys, you're not supposed to write the answer in the chat box. You're supposed to go to the menti.com. You're supposed to log in. Then only you can participate in the quiz. Right? Hi, Musab. Welcome, welcome, welcome. People, look at your screen. Look at your screen. It's a very, very simple question. Yes. You have got 28 more seconds to give it a try. Yes, Jagdish, you are doing wonderful, bro. You are doing wonderful. Yes. Janan, is that? That's actually great. If my hairstyle resembles with Russell the muscle, yeah. Yes, it's a bit lengthy question, yeah. I get it, I get it. The time is up. The time is up. The time is up. Okay. Okay, let's check the leaderboard, guys. Let's check the leaderboard. Let me see the results right now. Let me see the results right now. Let me see the results right now, guys. I think it's going to be a tie, I must think. Devil is the fastest to answer this question. Guys, you can just have a look on the margin. Devil is coming closer to Hadi. Yes, Hadi, you have to be careful. Devil is coming closer. And we have got Dev Khatriya, the 4th position. Wonderful. Then we have got Jagdish, we have got Janan, we have got Aditya, we have got Uncharted, we have got DM Kids, and we have got Amit still at the leaderboard. Yeah? Okay. So before moving on to the next question, let me show you how this question was to be solved. Yeah? Before moving on to the next question, let me show you how this question was to be solved. Let's look at the question, guys. 1 mole of O2 and 2 moles of SO2 were heated in a closed vessel of 1 liter capacity at equilibrium. 1.6 moles of SO3 were found. The equilibrium constant. All right. Let's see, first of all, you all must be knowing when O2 gas reacts with SO2 gas, what it leads to the formation of? It leads to the formation of SO3 gas. First of all, this is the reaction which will be taking place. Yes. Now, people, is the reaction balanced? No, it's not balanced. Let's try to balance it. This should be 2 times. This should be 2 times. Okay, the reaction is balanced. And people, at time t is equal to 0, at the initial conditions when the reaction was not started, I was having 1 mole of O2. Yes, this is that 1 mole of O2, and I was having 2 moles of SO2. Okay, and this is going to be 0 at time t is equal to 0, correct? Now, people, at equilibrium, let's assume out of 1 mole of O2, X moles are reacting. If X moles of reacting, I'll be left with 1 minus X moles of O2. Yes. Now, people, 1 mole reacts with 2 moles. So, X moles reacts with 2 X moles. I had 2 moles. Out of 2 moles, how many moles are reacting? 2 X moles are reacting. So, I'll be left with 2 minus 2 X moles of SO2 at equilibrium. Yes. Now, people, 1 mole gives 2 moles. So, X moles are going to give me 2 X moles. Yes. These are the moles of reactants and products at equilibrium. Yes. These are the moles of reactants and products at equilibrium. Correct? Now, people, at the same time, it's given in the question at equilibrium, 1.6 moles of SO3 were found. Yes. 1.6 moles of SO3 were found at equilibrium. These are the moles of SO3 at equilibrium. Yes. So, moles of SO3 at equilibrium, which is 2x. In the as per question, it's given as 1.6. So, x value you got as 0.8. Yes. You got the value of x as 0.8. Now, people, if you got the value of x, 1 minus x is going to be 1 minus 0.8. It's going to be 0.2. So, these are the moles of O2 at equilibrium. 2 minus 2x. So, 2 minus 1.6. 2x is 1.6. So, 2 minus 1.6 is 0.4. Yes. What is the value of 2x? It's 1.6. I got the moles of each reactant and product at equilibrium. Yes. What am I supposed to do? I'm supposed to write the equilibrium constant value. I'm supposed to calculate the equilibrium constant value. Yes. Now, people, am I given with the volume of the container? Yes, I'm given with the volume of the container, which is 1 liter. I'll be dividing these moles by 1. I'll be dividing these moles by 1 liter. I'll be getting the moles. I'll be getting the concentration of reactants and products at equilibrium to be same as that of moles. Yes, because number of moles I mean, because the volume of the container right here is equal to 1. Yeah. Now people, you can simply write the Kc expression. Kc expression is going to be concentration of SO3 at equilibrium, which is 1.6, raised by the stoichiometric coefficient, that is 2, divided by concentration of O2 at equilibrium, which is 0.2, multiplied by concentration of SO2 at equilibrium, which is 0.4, iska square. Yes, people, on solving, you are going to get the value exactly to be 80. Yes, you are going to get the value exactly to be 80 right here. So option C was the correct one among all. Wonderful, guys, who have made it correctly. That's actually great. I'm moving on to the last question, guys. I am moving on to the last question. Okay, and this last question is going to decide our topper of the today's session. So let me know if you're super duper excited for this last question as well. You have to be careful. Hadi and Kiran Kumar, they are actually merging into each other, yeah? And I am actually going to see who is going to kill it, okay? Because it's going to be a strong tie otherwise, yes? Yes? This is the final question. This is the final question. Are you guys ready? Are you guys ready for it? Let me know in the chat box. Hit the chat box with the thumbs up. Hit the like button of the video. Do share, subscribe the channel at the same time so that everyone will get benefit out of these sessions. Yes? Wonderful, wonderful, wonderful. I'm going to start the countdown in 3, 2, 1, and now. The countdown has started. Look at your phone, guys. Look at your phone. Look at your phone. For the reaction, NH4HS gives NH3 gas plus H2 gas. The equilibrium pressure at 25 degrees centigrade is this much. What is the Kp for the reaction? Very, very, very simple question. Yes? Very, very, very simple question. You have got exactly 1 minute 5 seconds to solve this question. I want every one of you to give it a try properly. Yes. And Srilata is saying it's done. That's wonderful, Srilata. That's wonderful. I want every one of you to give it a try properly, guys. It's a very, very simple question. Yeah. Yes. Yes. Arpan is also done, I guess. Ninja, Kiran Kumar is done with the question. Anish is done. Anmol is done. Kareto is done. Yes. Karan is done with the question. Faisal is done with the question. Janan is very, very serious about the question. Yes, the quiz is turning out to be very serious, guys. Okay, it is going to be the last one which is going to decide our topper. Yes, and this is happening the first time right now on this YouTube channel. Yeah. Okay, 19 more seconds. 19 more seconds. The same question, the same type of question. We started the quiz. I mean, we started the today's quiz with the same type of question, guys, if you remember, yeah? If you remember. The question is done, it seems. The question is done, it seems. The time is up. The time is up. Let's check, first of all, how many people are there who have made it correctly. Wonderful, guys. Majority of the kids have given the correct answer. Yes. Should I be showing you the leaderboard? Should I be showing you the leaderboard? Should I be showing you the leaderboard? Let me know in the chat box if you want me to show the leaderboard. Yeah? People are sweating, I guess. Is that? Is that? People are sweating, I guess. Is that? Kiran Kumar and Hadi. What do you think? What do you think, guys? Who is going to be the winner for the today's session? Let me know in the chat box. What do you think? What do you think? Who is going to be the winner of the today's session? What do you think? Or Kirito wants me to end it without showing the leaderboard. Is that? People are saying, Ashwarya is saying it's going to be Hadi. Shahid is saying it's Hadi. Karan is saying it's going to be Hadi. Yes? Yes? I'm not going to show you the leaderboard. Wait, let me see what do people think. What do you guys think? Who is going to be the topper? Who is going to be the winner of it? Yes? What do you think? Vijay is like, I'm able to hear my heartbeat. That's wonderful. I'm loving it, guys. Trust me, I'm loving it. Yes? Okay, I am going to show you the leaderboard in 3, 2, 1, and now. Let's check it. Let's check it. Let's check it. Let's check it. Let's check it out. Oh my goodness, what's going to happen? What's going to happen? Oh my God. Oh my God. What actually happened, guys? What actually happened? Can you actually believe it? Wonderful, Ninja Kumar. You got back your the first position. Yes. Wonderful, wonderful. Hadi, I'm really sorry, bro. I'm really sorry. Better luck next time. Yes. Yes. Kiran Kumar has killed it. Kiran Kumar, congratulations. Hadi, congratulations. You're still at the second position. Then we have got Dev Khatria, the third position. We have got Janana, the fourth position. We have got Jagdish, fifth position. We have got Aditya. We have got Uncharted. We have got DM Kids. And Amir was the fastest to answer this question. It was the epic quiz session, guys. I actually loved it. Yes. And I'm damn sure you would have loved it at the same time. Yes. Yes. Congrats, Kiran Kumar. You have made it. Yes. Congrats. So people, I'm damn sure you have enjoyed the... Yes, Hadi, it's a 13-point difference. Yes, it was just the 13 points of difference. It was actually the 13 points of difference. Yes. So people, I'm damn sure you would have loved the today's session. I loved it. I personally loved it. Okay, I actually loved it. And I'm damn sure you loved it at the same time. So people, let me tell you, on the next Sunday, we are going to have one more Menti session from the chapter Ionic Equilibrium. In the upcoming week, from tomorrow, we are going to start the Ionic Equilibrium. No, tomorrow we are going to do the Leaderboard principle, okay? Do not miss that session at all. That's very important session which I'm going to take at 5:30 tomorrow in the same channel. And from Tuesday, we are going to start the Ionic Equilibrium. And in the coming Sunday at 9 p.m., you are going to again have the Menti session with me from the chapter Ionic Equilibrium. Yes, it was actually the super thrilling session. So people, this was all from my side in the today's session. I'm sure you would have enjoyed this session. You would have loved this session. I loved it. You would have loved it at the same time. So people, let me take the leave now. I'll see you guys tomorrow at 5:30. Till then, you guys take care. Bye-bye. God bless you all and love you all. Take care, guys. Bye.